Hello everyone, my name is Rakshita Vishwanath Giri. I am a third year computer science engineering student from Sri Siddheshwar Women's College of Engineering, roll number 346. Today we are going to learn about a bottom-up evaluation of S-attributed definitions, which is very important part of a syntax-directed translation in a compiler design. This concept plays a crucial role when we deal with the semantic part of compiling, where we don't just check if a program is syntactically correct, but also understand what it means and how it generates its code. So in the first slide, it is nothing but the introduction. So to begin with let's understand what S-attributed definitions are. These are the type of a syntax directed definition in which only synthesized attributes are used. That means every attribute value is calculated based on only on its child nodes in the parse tree. Since the values go upward in the tree, it's a perfect match for bottom-up parser like LR parsers. And in the next slide, we are going to see what is a synthesized attribute. So now let's break down the what exactly is a synthesized attribute. Imagine you have a grammar production rule like E1 plus T. So in this rule, E is on the left side and E and T are on the right side. So if we write a semantic rule like this, so we are saying calculate the value of a E based on the values of E and T from the RHS, and this is the synthesized meaning computed from children and pushed up. So in the next slide, we are going to see the bottom-up evaluation. In a bottom-up parser, such as an LR parser, the tree is built from leaves to root. That means we start with the basic symbol and keep reducing them until we reach the starting symbol of the grammar. At every reduction step, we also compute the semantic values using the synthesized attributes. This is what we call a bottom-up evaluation. Each reduced steps triggers a semantic action. So in the next slide, we are going to see evaluation steps. So input tokens are scanned and shifted onto stack. Next one, parser reduces a production when a handle is matched, and then during reduction we apply a semantic rule and then compute synthesize the attribute using RHS symbol. So it is nothing but first the parser reads the input and then shifts token onto stack. It keeps checking if the top of a stack matches the right hand side of a grammar rule. If yes, it performs a reduction. And at this moment, we evaluate semantic rule attached to that production. Then the synthesized attribute is computed and passed up to the parent node. So every time a rule is reduced, an attribute is calculated. So in next slide, these are the example grammar and semantic rules. So let me now show you a grammar with semantic rules. So here is a simple arithmetic expression grammar. Each of these rules contains only synthesized attributes. So when we parse something like 3 plus 4 multiply 5, the parser reduces step by step, calculates values at every node. And in the next slide, we are going to see the sample parse tree. As you can see here, um, now look at the parse tree diagram. This shows a bottom-up parse for the expression 3 plus 4 multiply 5. Let's walk through it. At the bottom, the leaf nodes are 3, 4 and 5. Then as we go up, the parser first reduces 4 into 5 and gets the value 20. Then it reduces 3 plus 20 and gets 23. Then these values are shown at each node as a synthesized attributes. For example, t dot value is equal to 20, e dot value is equal to 23, and so on. This tree visually explains how values go from bottom to top, which is exactly how synthesized attributes are supposed to work. And in the next slide, we are going to see the key points. So, as attributed definitions work best with the bottom-up parsing, and then all values flow upward in the parse tree, common in arithmetic expression evaluation. So it is nothing but as attributed definitions are simple and bottom-up friendly, and then all attributes are synthesized, no inherited attributes involved. Then semantic actions are triggered during reduce steps. Then this method is most commonly used for expression evaluation, code generation, and similar tasks. Then tools used, tools like YACC Bison support synthesized attribute evaluation. Semantic actions can be inserted after production rules. So in real world, as we know, compilers who use tools like YACC or Bison to automate parsing and attribute evaluation. These tools allow us to define semantic rules just like we saw, and the parser will automatically evaluate them during a parsing. So you just write the grammar and attach the semantic actions. So in next slide, we are going to see conclusion. So it is nothing but to wrap up a bottom up evaluation of S attributed definition is an essential concept in compiler design. It let us attach meaning to syntax in a structured and mechanical way. Whenever the parser reduces something, it doesn't just build a tree, it also builds meaning, like calculating the value of an expression. This idea is central to code generation, and then expression translation, and many more. So always remember, synthesized attribute go up, and the bottom up parser works perfectly with them. So thank you for watching this video.